Good afternoon, everyone. In yesterday's lecture, we completed with supervised learning ANN. That means we completed with what perceptrons are, what is MLP, and what is RBFN. So, if anyone has studied after the lecture, so if you are having any doubt in that, you can ask me before we start with our today's session. So, today we will start with what are unsupervised ANN, what are deep neural networks, and what are convolutional neural networks. So, as we know that unsupervised means that without any assistance from any other object. So now we have to train our neural network in such a way that we do not need help from the outside. Till now, when we were talking about the normal neural networks, in that context, there we were just inputting all the inputs that we had. We were assigning the weights, we were doing the processing, adding with the bias, passing through the activation function, and calculating the output. But now, what will happen is that ऐसा हो सकता है, there can be a situation where the inputs that we have are somewhat similar. So the inputs, those will be similar in nature. Those kind of inputs are joined together and formed into a cluster and passed through the same process. And for those clusters, we obtain the different patterns as the output. Now, what it is, how it is done, that we will study in unsupervised learning neural network and the various types that we are going to discuss. So, as the name suggests, this type of learning is done without the supervision of a teacher. This learning process is independent. During the training of ANN under unsupervised learning, the input vectors of similar type are combined to form clusters. When new input pattern is applied, then the neural network gives an output response indicating the class to which input pattern belongs. Now, as they have mentioned, and as I was telling you, so what happens is here we are making use of data mining techniques, classification and clustering. So for the inputs which are similar in nature, they will be clustered together and considered as one input. All the processing is done, passed through activation function, and the output is calculated. Now, if you remember, yesterday we were talking about that dataset example in case of RBFM, where we had blue crosses and red circles. There we were classifying or categorizing the output based on the boundary line that we were obtaining. We had negative and positive outputs, and we were considering the positive outputs because they were closer to the value of 1, I'll not go in that much detail over here now. We have already discussed that. यहाँ पर भी they are trying to say the same thing. Like the clusters, input clusters are passed, and the output that we will obtain is actually classified into different categories. When a new input pattern is applied, when the neural network gives the output response, indicating the class to which the input pattern belongs. In this, there would be no feedback from the environment as to what should be desired output and whether it is correct or incorrect. Hence, in this type of learning, the network itself must discover the patterns, features from the input data and the relation for the input data over the output. So, previously, in case of supervised, we were there to check if the output that we are obtaining is according to the output that we desire or not. So accordingly, we used to apply backpropagation, change the value of weights, and try to make the output more accurate and desirable. But that is not the case over here. Over here, it is that we have to train our neural network in such a way that it is able to recognize the patterns of the data set and give the output accordingly. Next, the human brain, its functions, and the way it works served as the inspiration for the creation of neural network. AI and ML, which is the subset of AI, plays an essential part in its functionality. It starts working when a developer enters data and builds a machine learning algorithm, mostly using the if else principle of building a program. The deep neural network does not only work according to the algorithm, but also can predict a solution for a task and make conclusions using its previous experience. In this case, you do not need to use programming or coding to get an answer. So, till now, when we saw an architecture or diagram of neural network, we just saw that there was one input layer, there was a hidden layer when we were talking in context of MLP and RTFM, and there was an output layer. But as you can see over here in this diagram, it has three hidden layers, one input layer and one output layer. So over here, we have more neurons. The processing and computing time will also increase, and the output that we'll get from this type of network will be very much accurate. And there is one more thing that such kind of neural networks does. It stores its experience. Whatever it will learn during the training process, it will store its experience, and further, when there will be a situation, it will make use of its experience and give the output. Nodes are little parts of the system, and they are like neurons of the human brain. When a stimulus hits them, a process takes place in these nodes. Some of them are connected and marked, and some are not. But in general, nodes are grouped into layers. The system must process layers of data between the input and the output to solve a task. The more the layers it has to process to get the result, the deeper the network is considered. There is a concept of credit assignment path, which means the number of such layers needed for a system to complete a task. The neural network is deep if cap index is more than 2. So, if you have more than 2 hidden layers, the network that will be having will be considered as deep neural network. So, this type of network is beneficial when you need to replace human labor with autonomous work without compromising its efficiency. A deep neural network usage can find various applications in real life that I'll not go into detail. We will discuss about the applications in your lab sessions. So, next question that we have is, what is the difference between the normal neural network and deep neural network? Now, according to the diagram that we have, is that in case of normal neural network, there were less number of neurons, the complexity was less, there was just one hidden layer, and there was provision of backpropagation. But in case of deep neural network, as it is part of unsupervised ANN, such things are not there. So a neural network is not a creative system, but a deep neural network is much more complicated than the first one. It can recognize voice commands, recognize sound and graphics, do an expert view, and perform a lot of other actions that require prediction, creative thinking, and analytics. Only the human brain has such possibilities. The neural network can get one result, a word, an action, a number, or a solution, while the deep neural network solves the problem more globally and can draw conclusions or predictions depending on the information supplied and the desired result. The neural network requires a specific input of data and algorithms of solutions, and the deep neural network can solve a problem without a significant amount of marked data. So these were some of the differences. Next, we will discuss about what is deep neural network. The deep neural network needs to learn all the time to solve tasks in more qualified manner, or even to use various methods to provide a better result. When it gets a new information in the system, it learns how to act accordingly to a new situation, just like a human brain. So, if we talk in our context, if we have a particular situation or we have certain new information, we perceive that information and act accordingly. So is the case with deep learning neural networks. Learning becomes deeper when tasks you solve get harder. Deep neural network represents the type of machine learning when the system uses many layers of nodes to derive high-level functions from input information. It means transforming the data into a more creative and abstract component. In order to understand the result of deep learning better. Let's imagine a picture of an average man. Although we have never seen this picture and his face and body before, we will always identify that it is human, differentiated from other creatures. This is an example of how deep neural network works, like how your brain perceives when you are told that okay, consider or imagine an average looking person. So your brain automatically starts creating scenarios like, okay, this is how a person might look like. So here they are trying to say that deep neural networks also works in same way. Creative analytical components of information are analyzed and grouped to ensure that the object is identified correctly. These components are not brought to the system directly, thus the ML system has to modify and derive them. Now we have discussed about what actually is deep neural network, and if you are okay with this thing, so we'll move forward. Or if you have any doubt, you can ask me right now. Okay, so the next question that we have is, what is deep convolutional neural network? There are different types of neural networks, and the differences between them lies in their work principles, the scheme of action, and the application areas. CNN are mostly used for image recognition and rarely for audio. It is mostly applied to images because there is no need to check all the pixels one by one. CNN checks an image by blocks, starting from the left upper corner and moving further pixel by pixel up to a successful completion. Then the result of every verification is passed through convolutional layer where data elements have connections while others don't. Based on this data, the system can produce the result of the verifications and conclude what is in the picture. This is how things work in deep CNN, and I guess now you are able to identify the basic differences between the normal neural network, MLP, RBFN, and deep neural networks. So over here they mentioned that CNN are basically used for image recognition only and not for audio recognition. Because when we talk in context of audio, there are many things that are needed to be checked. First of all, the actual basic sound, the bass. After that, if the audio has certain kind of sound, if the audio is of certain music, then what are the instruments used to create that music? There are many factors. But when we talk in context of image recognition, over here they said that they don't check the pixels, they check the blocks. They check the blocks present in a particular picture, and accordingly it moves from left upper corner towards the right side and checks the complete image and tries to identify what is depicted in that particular image. This is how CNN works. Now, next we will discuss more deeply about CNN. CNNs are regularized versions of multi-layer perceptrons. MLP usually mean fully connected network, that is, each neuron in one layer is connected to all the neurons in the next layer. The fully connectedness of these networks makes them prone to overfitting data. Typical ways of regularization include adding some form of magnitude measurement of weights to the loss function. Loss was something that we discussed when we first talked about neural network in chapter number 1. If you want to know more about it, you can refer to that video. CNNs take a different approach towards regularization. They take advantage of hierarchical patterns in data and assemble more complex patterns using smaller and simpler patterns. Therefore, on the scale of connectedness and complexity, CNNs on the lower extreme, convolutional networks were inspired by a biological process in that the connectivity pattern between neurons resembled the organization of animal visual cortex. Now, if you have seen how a neuron or a human neuron looks like, it is actually a cell and it has a cortex. It has a stem like structure through which it connects to the other neurons present. So, over here, they are saying that CNN was inspired by the neuron, the animal or human neuron, and how it used to look like the basic cell structure and the cortex part. Individual cortical neurons respond to stimuli only in restricted region of the visual field known as the receptive field. The receptive field of different neurons partially overlap such that they cover the entire visual field. CNNs use relatively little preprocessing compared to other image classification algorithms. This means that the network learns the filters that in traditional algorithms are hard engineered. These independence from prior knowledge and human effort in feature design is a major advantage. Now, if any one of you have ever worked on either speech recognition or image recognition, you must know how difficult it is to process all the images and to get the data through all the images. So over here, CNN is making our process simpler because it does not require any pre-processing basically, and does not actually, it reduces the human effort, remembers what we have trained it, how we have trained it, what input we put at that time, and accordingly it gives the output. Now, its architecture. A CNN consists of an input and an output layer, as well as multiple hidden layers. The hidden layers of a CNN typically consist of a series of convolutional layers that convolve with the multiplication or other dot products. Convolve means basically to multiply, to form from one object to another object, उसको कॉन्वॉल्व कहते हैं कि एक लेयर से दूसरी लेयर तक हम कैसे जा रहे हैं using the process of multiplication. The activation function is commonly a ReLU layer and is subsequently followed by additional convolutions such as pooling layer, fully connected layers, and normalization layers, referred to as hidden layers because their inputs and outputs are masked by the activation function and final convolution. Though the layers are colloquially referred to as convolutions, this is only by convention. Mathematically, it is technically a sliding dot product or cross correlation. This has significance for the indices in the matrix in that it affects how weight is determined at a specific index point. Now, its way of calculation of output is very much different as compared to what we have studied in normal neural networks because over here the processing is complex. So, we will be making use of input vectors. Now, if you remember when we were talking about fuzzy logic over there, how we were multiplying two matrices and what output we were getting. The processing of such layers are actually based upon the vectors, not on the actual numbers. So that is why it is complex. And more the number of hidden layers, more the complex its calculation becomes. Next we have is convolutional. When programming a CNN, the input is a tensor with shape. Now tensor is a mathematical term and it represents certain oval structure in which neurons can be collected. So the input is a tensor with a shape, number of images, x, sorry not x, we are multiplying it, image height multiplied with image width multiplied with image depth. Then after passing through the convolutional layer, the image becomes abstracted to a feature map with shape, that is number of images multiplied with feature map height multiplied with feature map width multiplied with feature map channels. A convolutional layer within a neural network should have the following attributes: convolutional kernels defined by width and height, that is the hyperparameters, the number of input channels and output channels, the depth of convolutional filters must be equal to the number of channels of the input feature map. So Further, they have mentioned the convolutional layers convolve the input and pass its result to the next layer. This is similar to the response of a neuron in the visual cortex to a specific stimulus. Now, by visual cortex, as they have mentioned, they are talking about the neurons present in our eyes. So, how our eyes respond to a particular stimulus, that is what they are concerned about, and on basis of that they have created this convolutional neural network. Each convolutional neuron processes data only for its respective field, although fully connected feed-forward neural network can only be used to learn features as well as classify data. It is not practical to apply these architectures to images. A very high number of neurons would be necessary, even in shallow architecture, due to very large input sizes associated with images, where each pixel is relevant variable. Now, I think you are also able to understand this thing, that our eyes can see different things around us, can able to identify different things, can able to identify the various colors. But when we talk about an algorithm, when we talk about training an algorithm in such a way so that it behaves like how our eyes identify things, it can be a bit of cumbersome task. So this is what they have mentioned over here. So if you want, please study about such things for your better understanding. This was it for today. Rest we will discuss in your next lecture on Tuesday. Anyone having any doubt in today's lecture, please ask. Okay then, let's move to your attendance. Class TC1-67,
Yes, ma'am.
9, 12, 19, 37, 63, 67, 69, 73,
Yes, ma'am.
77,
Yes, ma'am, 77.
79, okay, 80,
Yes, ma'am. 80.
then 85,
Yes,
86,
ma'am, 85.
100,
100.
108, 112, 113,
Yes, ma'am.
119,
Yes, ma'am.
127, 129. Yes, Heta, I have
Yes,
marked you. 130,
yes, ma'am.
135, 136. Yes, you guys got it. 164, 190. Class CC2 18 series 9. Roll number 7. Roll number 11, 29, 58, 68, 71, 75 is there, 78, 84, 88, 89, 96, 97, 103, 115, 117, 118, 133, roll number 7 कौन याद आ रहा है 173. Class TC3, roll number 4, 40, 172, 182, 18 series 1, 18 series 12. Okay, 1 is there, 182 is there. All right. Okay, students, thank you.